lesson 26, February the 16th through the 19th. We're looking at recursive challenge problem, the double and add 5 game. Alright, so let's go ahead and look at what this says. It says the double and add 5 game is loosely related to the Coltez conjecture, an unsolved conjecture in mathematics named after Lothar Coltez, who first proposed the problem in 1937. The conjecture includes a recurrence relationship, triple and add 1, as part of the problem statement. A worthwhile activity for you and your class is to read about the conjecture online. Okay. So we're going to look at what they call the double and add 5 game. Alright? So let's look at example number 1. This activity is going to describe the process. Alright? I want to create an interesting sequence by doubling and adding 5. So let's work through the table and see what we're going to do. Alright, so I have my starting number. Alright? So our starting number is 1. Alright, so this is our starting number, 1. I am going to double that. Alright, double means to multiply by 2. And then I'm going to add 5. Okay? So when I do that, 1 times 2 is 2, plus 5 is equal to 7. I get the result of round 1. Alright, I get the result of round 1. Alright, so now I'm going to take that answer and that's going to become my starting number. Alright, so now 7 is my starting number. So I'm going to double, which means to multiply by 2, and add 5. Guys, remember, I'm going to multiply first. So 7 times 2 is 14. 14 plus 5 is 19. And I get the result of round 2. Alright? Alright, so now I'm going to take 19. So I'm going to double and add 5. So 19 times 2 is 38. 38 plus 5 is 43. That's my result of round 3. Alright, I'll take 43 here. We'll do 43 times 2 plus 5. So 43 times 2 is 86, and 86 plus 5 is 91, which is the result of round 4. Alright, I'm going to take 91. So we have 91 times 2 plus 5. So 91 times 2 is 182. 182 plus 5 is 187, and that is the result of round 5. So we had 5 rounds. Alright? We have 5 rounds. Alright, so what I want you to do is I want you to pause your video, and I want you to work through exercise number 1. Complete the table below for the given starting number. Alright, so it gives you a starting number and it wants you to do this. Alright? So pause your video, work through this. Alright, so we have 2. We're going to double that. and add 5, so I get 9. I'm going to double 9 and add 5, I get 23. So I'm going to take 23 and double and add 5, so that'd be 46 plus 5 is 51. Alright, so that's what you should have for the first table. Alright, my starting number here is 3. So 3 double and add 5. So I get 11. Alright, 11 double and add 5. So I get 27. Take 27 and double and add 5. And I get 59 is what you should have for the second. Okay. So let's look at this. So the whole goal of this, given a starting number, double it and add 5 to get the result of round 1. Double the result of round 1 and add 5, and so on. The goal of the game is to find the smallest starting whole number that produces a result of 100 or greater in 3 rounds or fewer. Okay, so please pause the video, and I want you to see if you can figure out the smallest number I can start with that will give me, excuse me, a result of 100 or greater in 3 rounds or less. Alright, so I'm only going 3 rounds or less. Alright, so pause your video. Alright, so I wish you were here so I could ask you questions on what you decided to do. But let me ask this question. Does starting with 10 produce a result of 100 or greater in round 3? Well, let's look at this. If I have a starting number of 10. Alright, and remember I want it to be 3 rounds or fewer. So 10 times 2 plus 5. So that gives me 25. Alright, so take 25. 25 times 2 is 50 plus 5 is 55. 55 times 2. 55 times 2 is 110, plus 5 is 115. So it says, my question was, does it produce what we're looking for? 10 does give me a result of 100 or greater in 3 rounds or fewer. Okay, it took me 3 rounds, but I got a result of 100 or greater. Why will all numbers greater than 10 work? Well, if 10 works, then I know that the more I multiply and the more I add, it's going to work. So anything greater than 10 is going to work. But remember, our goal is to find the smallest. So let's go, let's look back here. So 2, did that result in a number 100 or greater within round 3? No. Look at 3. Did that give me 100 or greater in 3 rounds or less? It did not. Looking at 1, it did not. So anything under 3 is not going to work. Alright, so now I've got somewhere between 4 and 9 that I've got to figure out which is my smallest. Do you see any patterns in the table that we've already created? Alright, so look at this. Do you see any patterns that we have created? Well, let's look at this. I started with 1 here and got 43. I started with 2 here and got 51 at round 3. I started with 3 here and got 59 at round 3. look what happens. 48 to 51 is 8. Or I'm sorry, 43 to 51 is 8. 51 to 59 is 8. They're increasing by 8. Alright, so let's see what we can figure out. Alright, we can go to 9. Alright, I would suggest you just kind of go 9. Alright, so 9 times 2 is 18, plus 5 is 23. Alright, so 23 times 2 plus 5. So 23 times 2 is 46. 46 plus 1 is 51. 51 times 2 plus 5. 51 times 2 is 102, plus 5 is 107. Did 9 work? Yes, it did. But once again, our goal is to be the smallest. Alright, so let's see. We'll go 8. 8 times 2 is 16, plus 5 is 21. 21 times 2 is 42. 42 plus 5 is 47. 47 times 2. 47 times 2 is 94. Plus 5 is 99. Did 8 work? It did not. So what is the smallest that I can get? 9 is the smallest that I can start with to get a number that produces the result of 100 or greater in 3 rounds or fewer. Okay? So this was a yes, this was a yes, this was a no. Alright, so 9 is my smallest. Okay. So I don't know if you had any other methods. If you did, great. You know, there's a few other methods that you could have taken with this. Maybe you could have looked at it like this. If 100 is reached in 3 rounds, then I would take 100 minus 5, which is 95, and divide that in half, which gives me 47 and a half, which means I have to reach 47 and a half in 2 rounds. Alright? So, you know, you can figure some things out differently. Alright, so our next goal is to solve the same problem, but find the smallest number that results in 1,000 in 3 rounds or less. Alright, so now we want to find 1,000 in 3 rounds or less. This is not as easy as the starter problem to solve by guess and check. So we're going to formulate an equation. Alright, so there's some things I need to explain to you. Alright, so we're going to let A sub 1, alright, be the number of the result of round 1. Alright, so that's our number result of round 1. We can also we can label the result of round 2 as A2. Okay, and so on. Alright, and you can continue doing that, just putting that subscript number for whatever round. So how, if we do this for the starting or the number result of round 1, how could we label the starting number? Well, I want to know how do I label my starting number? We would label that as A sub 0. That is our starting number. Alright, that is our starting number. Alright, so let's look at how we would write this as an equation. All right, let's go back to well, I'll tell you what, let's create a new chart here. All right, so we'll start with our number. All right, this is our double and add 5. And then we're going to write this as our equation. Okay? All right, so we'll do our starting number as 5. Now, how did we say we would label our starting number? That is a sub 0. All right, so we do 5 times 2 is 10 plus 5 is 15. All right, I'm just going to do a couple here. 15 times 2 is 30, plus 5 is 35. 35 times 2 is 70, plus 5 is 75. And we'll stop there for just a minute. Okay, so what would this be? This would be a sub 1. This would be a sub 2. Okay? Because this is round 1. This was what we got after round 1. This is what we got after round 2. And we would keep going from there on. All right, so how would we write our equation? Our equation here would be a sub 0 times 2 plus 5, and that's going to give me a sub 1. Okay? So now I take a sub 1, multiply it times 2, add 5, and that's going to give me a sub 2. And we can keep going on. A sub 2 times 2 plus 5 would give me a sub 3. Alright? And I can keep going on and on and on because I know that a sub 3 is 75. So we can look at that. Okay. So the ordered list of terms are 5, 15, 35, and 75 can be described as the initial value. A sub 0 is equal to 5. And the recurrence relation of a sub I plus 1 is equal to 2a sub I plus 5. Okay, so what do I mean here? Let's talk about the extension of this table. I can keep going on and on and on and on and on. As long as I have numbers, I'm going to keep going. Okay, so I'm going to represent that as a sub I. In other words, that tells me it's never ending. I'm going to infinity. Alright, and then what happens to the next one? I get a infinity, or a sub I plus 1. Okay? So then, here's what would happen. I would have a sub I times 2 plus 5 is equal to a sub I plus 1. Alright? Okay. So, this is an example of a recursively defined sequence, or a recursive sequence. Alright? So, let's see if we can figure out how to use this. So, let's use the generic initial value of a sub 0 and the reoccurrence relation a of I plus 1 is equal to 2a sub I plus 5 to find the formula for a sub 1, a sub 2, a sub 3, a sub 4 in terms of a sub 0. Okay. 1. So I know that a sub I plus 1 is equal to 2a sub I plus 5. Alright, so if a sub 1, that would actually be 2 of a sub 0 plus 5. Alright, because what am I doing? I'm multiplying a sub 0, this starting point, this initial value, plus, and then adding 5. Alright, so let's talk about what I would be doing to 2, or a sub 2. Well, I'm doubling that again, so I'm doubling this. Alright, I'm doubling this, and then adding 5. So I can simplify that. So I get 4 a sub 0 plus 10 plus 5. So that gives me 4 a sub 0 plus 15. So in other words, it's telling me that I can take my initial value, multiply it by 4, and add 15 to get the result of round 2. Alright, let's look at a sub 3. Well, I'm taking this and multiplying it by 2. And then adding 5 again. So I get 8 a sub 0 plus 30 plus 5. So I get 8a sub 0 plus 35. Alright. A sub 4. I'm taking this and multiplying it by 2, because I'm doubling it, and then add 5. So I get 16 a sub 0 plus 70 plus 5 gives me 16a sub 0 plus 75. Alright, so this is what it's telling me, is I can use my a sub 0 and find that relationship. Alright, so let's look at this. If I want to know, will I get 100 or greater in 3 rounds or less, then my shortcut would be this. Here's my initial value. Alright, so I'm going to multiply that times 16 and add 75. Alright, so that would be what? 9 times 16. 144 plus 75. That would give it to me. That would work. Alright? So I know I'm going to get, and actually I wouldn't even have to go to that one. I could go to round 3, because they wanted it in 3 rounds or less. So I could do 8 times 9 plus 35. That's 72 plus 35. That gives me 107. So that would work. I could plug in something here and figure out, would that give me what I need. So let's go back for just a second. We said we want to find 1,000. Alright, well let's see what 10 would give us. So 10 times 8 plus 35 is 80 plus 35 is 115. That's not going to work. So let's go bigger. Let's go to 20. 20 times 8 plus 35. That's 160 plus 35. That's not going to work, is it? Let's go to 100. Let's go to 100. 100 times 8 plus 35 would give us 800 plus 35. That's still not big enough. Alright, let's go to 110. 110 times 8 plus 35 is 880. plus 35. That gives us what? 915. So it's still not right. Alright, so let's go to 112. So I get 896 plus 35. It's 11, 13, that's 931. So you can see we're getting closer and closer to our goal, but we haven't quite gotten there yet. So you can use these to figure out where 1,000 would fall. Where would I be able to get 1,000 in 3 rounds or less? Alright, please make sure you read through our vocabulary. They are super important. Guys, if you have any questions, please make sure you reach out to me. And have a great rest of the week.